Week 20, maintenance, pure maths 1, here we go. First one, you notice we've got powers, I shouldn't have this, I keep on doing this for some reason. We've got powers of 4 and 8, so I'm going to make y equal to x to the 4, and I could rewrite this whole equation as y to the y squared minus 15, y take away 16 equals 0, and I think very easily I can factorize this as y minus 16 into y plus 1 equals to 0, so I've got y equals 16 or minus 1. Now because the power is a positive power, it's to the power of 4, there's no real solutions using this one, so I can just leave that. And so if y equals 16, therefore x equals plus or minus the 4th root of 16, so it is equal to plus or minus 2, and there we go, sorted. Let's move on to the next question. We've got a function here, and it's defined with the domain as x is greater than or equal to p, where k and p are constants, and we've got to express it in this completed square form. Okay, cool. So I'm going to complete the square by going x minus 2, take the square of that, take away 4, and then I've got plus k. So there we go, that one's done. And the range. Now the range will be in terms of k, well, assuming that p is the allows for the minimum point. Let's say that p is 2. I don't know, this question isn't worded particularly well, but if p is 2, then we can say that the range would be greater than or equal to k minus 4, because if we put a 2 in here, we'd get 0, and then we'd have minus 4 plus k, or k minus 4. So that's what I'm going to say for that one. The smallest value of p for which k is 1 to 1, p equals 2, because if you went any lower than 2, you're passing the minimum point. So what do we got? We've got a point at minus 2. So let's say this is at minus 2 comma minus 4 plus k. Now if you go any further to the left, you're going to get a 1 to many when you turn it into an inverse, and we want 1 to 1, so we just want on this side of 2, that would be 1 to 1. If we go any further to the left, it wouldn't be 1 to 1 anymore. Okay, for the value of p found, yeah, so now we've got to find the inverse. Now when you're doing an inverse with a quadratic, I want you to do it with the completed square version. So we're going to go y equals to x minus 2 squared minus 4 plus k, and we swap in our x and y values, so we get this as our second step. Now I'm going to bring everything across to the the right hand side, so I'll have x plus 4 minus k equals y minus 2 all squared, and then I'll take the square root of both sides. So we'll get plus or minus the square root of x plus 4 minus k. Let's take this over to here, and so we'll get y equals 2 plus or minus the square root of x plus 4 minus k. And at this point we're going to decide what we want. Now because we've already found earlier that we wanted on the right hand side of the minus 2, so therefore we can dispense with the negative, so our final answer will be the inverse is going to be 2 plus the square root of x plus 4 minus k, and that'll be the answer there. Now the next one is a coordinate geometry question, and we're trying to find a perpendicular bisector. So first of all we want to find the gradient, so gradient AB, change in y over change in x, so 1 minus minus 5 all over 7 minus minus 1, so we get 6 over 8, which is 3/4, and therefore the gradient of the bisector should be equal to the negative reciprocal. That's a 4 there. So it'll be negative 4 thirds. And then we want a midpoint for AB, because we're doing a bisector. And we just add the x values together, divide by 2, add the y values together, divide by 2, and so that gives us 3, comma negative 2. Now we use y minus y, 1 equals m into x minus x1. So we chuck in our midpoint, so y minus minus 2 equals m, which is our gradient of negative 4 thirds, into x minus, now we've got a 3 here. We get y plus 2 equals negative 4 thirds x plus 12 over 3, which is 4. Is that right? Yep, I think so. And then we just bring that 2 across, we get y equals negative 4 thirds x, and then plus 2. I think I've done that right. And we're trying to find meeting the x-axis at C and the y-axis at D. Okay, I got a different answer this morning, and I'm just wondering if I did something wrong, and I'm just doing this quickly. Let me just check. I think I got my midpoint right. Let me just see. Y minus minus 2. Yep. Minus 4 thirds x. Yeah. You know, I think I'm good. Okay. And so D is at the y-axis. Well, let's say C is at the x-axis, so that's when y equals 0. And D we can just use this, can't we? So D is the y-intercept, which is 0, 2. And for C, we know that it happens when y equals 0, so 0 equals 4 thirds x plus 2. Negative 4 thirds. And so we can say 4 thirds x equals 2. And we get 6 over 4. So x equals 6 over 4, which is 3 over 2, 1.5. And so coordinates for C is 3 over 2, comma 0. And we want to find the distance, so the distance is the square of both together. So distance CD, we're going to go the change in y squared plus the change in x squared, and then we just take the square root of that. So I don't know, what is this giving us? Screw it, so it's 5 over 2, I think. Is our final answer for the magnitude there. Okay, circular measure, what have we got here? I've got this diagram. AB is an arc of a circle. I've got a center O, and the line XB is a tangent to the circle. Okay, so you know you've got a 90-degree angle there. Okay. And A is the midpoint there. Okay. Well, fine. So that means this is R and this is R. Okay. So show that angle OAB is 1/3 pi radians. So I guess we can go cosine theta equals R over 2R equals 1/2, and therefore theta is equal to 1/3 pi. Okay, Now I'm going to express the perimeter and the area in terms of r, pi, and okay, and square root 3. So I'm going to do the perimeter first. So you can see from a to x is r. That's that bit there, right? A to x is r. Now I'm going to think about this bit here, AB. AB. Now AB is r theta. R theta. R times, and we know that theta we've already worked out is pi over 3. And then this bit here, we can use either Pythagoras or trigonometry to work out. So I would probably do Pythagoras. So it's going to be the square root of 2r squared minus r squared. And so if we bring this to the next line, we get r plus pi plus square root, and that would be 4r squared minus, I think, square root 3r squared. And I guess we could say this is like r plus pi plus square root 3r. And then we can go, well, this is like r into 1 plus pi plus square root 3. And that would be our final answer there. Now let's consider the area. This is the shaded area. We can think of it as half r squared theta is the area of the triangle, and then we're going to subtract the area of the sector. So the area of the triangle is half times r times 2r times half AB sine pi over 3. And then we're going to subtract the area of the this bit here, the sector, which is half r squared theta. So half times r squared times pi over 3. And I guess we can say this is like r squared. Now sine pi over 3, what is sine pi over 3? Sine pi over 3, I should memorize this, shouldn't I really? Square root 3 over 2. So square root 3 over 2, because that half and that 2 cancel each other out. So that's the first bit. And then we're going to take away r squared pi over 6. And I guess we can take r squared out of that and go, it's like square root 3 over 2 minus pi over 6. And that'll probably do. Alrighty then, moving on to the trigonometry question. We've got to solve this equation. Now you can see I've got sine and cosine. We want to get rid of them, so we've just got one ratio, so I'm going to use tan. So I'm going to get tan 2x equals 2. So I've just divided this cosine x across to this side, leaving the 2 on the right hand side. And therefore 2x equals the inverse tan of 2. Now I'm just going to change my domain that I'm looking at here, so I'll double it since I'm using 2x here. So when we go inverse tan of 2, now we want to be in degrees, so you probably need to change your calculator from the previous question. Inverse tan of 2 is 63.4. So 2x equals 63.4, and we know that there is a repeat every 180, so the next one would be 243.4, and that's the only ones that we have in the range. So therefore x equals, and we're just going to divide both of those by 2, so 31.7 degrees or 121.7 degrees, and that would be it. Now the next one is a series question. We're trying to find the coefficient of x to the power of 6. Now I always, if I'm struggling a little bit, I just do a little test. I do the first one, so 7 choose 0, then we'd have 2x to the power of 3 to the power of 7 and then we'd have the next one would be minus, and I'll put this as x to the negative 2, would be 0. And so you can see that you're going to have x to the power of 21 here, which is not what we want. So let's see what it jumps when we go to the next one. 7, choose 1. We're going to have 2x to the power of 3, and that would be to the power of 6. And then we'll have this negative x to the negative 2, and that'll be to the power of 1. So you've got 3 times 6 is 18, take away 2, which is 16. So you see from here to here, you're dropping 5 powers. Okay, so the next one should be 16, the next one should be 11, and then the next one should be 6. So you want 7, choose 3, and then it'll be 2x to the power of 3, and then multiply by negative x to the negative 2. This one now is going to be to the power of 3, and so this must be to the power of 4. So that's the one we want. Okay, well, 7, choose 3. I'm getting 35. And then I'm going to times it by, now 2 to the power of 4 is 16, x cubed, oh sorry, x to the power of 12, and then times negative x to the power of negative 6, that's a 1 there, so 112, and so we get 35 times 16, which is 560, but it'll be negative 560 because of that negative power, x to the power of 6, therefore coefficient is, of course, negative 560. Okay, geometric progression, second to last question. In the geometric progression, the second term is 9 less than the first term. The sum of the second and third terms is 30. Given all the terms of the progression are positive, find the first term. Okay. Alright, well we know that we've got A. We don't know A, but we know that A, is it geometric? Yeah, AR equals A minus 9. Okay. And what else do we know? And we also know that the sum of the second and third term is 30. So I guess AR plus AR squared equals 30. Now, what could we do here? Interesting. I guess we could do some substitution. We could substitute this in for AR. Yeah, AR. Then, that's a bit tricky, isn't it? I guess we might need to do a little bit more work with this one here. So we'll go R equals A minus 9 over A, because I've got to get rid of that A there. That's what I'll do. And I guess we can rewrite this as, let's do this one. A minus 9, so that's the first term then, plus A into A minus 9 over A all squared equals 30. And we get A minus 9 plus A into A minus 9 squared over A squared equals 30. And I guess I can go A minus 39 equals A, plus, and I can cancel this A and one of those out. So it will be A minus 9 all over A equals 0. and then I can just times everything by a. So I'll get an a squared minus 39a plus a minus 9. Oops, sorry, that should be squared there. Squared. Now I will open up that bracket, so I'll get a squared minus 18a plus 81 equals 0. And then I gather my like terms, so I've got 2a squared minus 57a plus 81 equals 0. And I'll probably just use the quadratic formula here. And when I do, I'm going to get a equals 27, or 3 over 2. But we know, if we read the question, all terms of the progression are positive. So for them to all be positive, we have to ignore this one because the second term is 9 less than the first term. So 9 less than 3 over 2 is less than 0, so it can't be that one. So I'm going to say A must be 27. Okay, so the final one is a differentiation question. Okay. This curve intersects the x-axis at A, the tangent to the curve at A intersects the y-axis. Okay, so let's find out where this curve, first of all, intersects the x-axis. So it does when 0 equals 10 over 2x plus 1 minus 2. So we just make 2 is equal to 10 over 2x plus 1. So you can see that 4x plus 2 equals 10. So 4x equals 8. So x is equal to 2. So C is at 2, 0. That's where it intersects. Now, the tangent to the curve at that point. Oh no, it's not C, sorry, that's actually A. I need to read the question properly. Okay, that's A. Now, I need to find a tangent to the curve. So I'm going to rewrite my original curve like this. 10 into 2x plus 1 to the power of negative 1 minus 2. Now, I'm going to say, to differentiate this, I'll use my chain rule. So u equals 2x plus 1, and therefore du dx is equal to 2, and y equals 10u to the negative 1. And so dy du is equal to negative 10u to the negative 2. Now we put it all together, dy dx is equal to this times this. So we're going to get negative 20 over u squared. Now u squared is this. We're going to square that. And that's our gradient curve. Now the tangent at curve to the curve at A intersects the y-axis at C. Oh, I don't know that I actually tangent to the curve at A. Okay, so now I'm going to put in that value of 2 into here. So what will this give us? So dy dx at 2 equals, so we're going to have negative 20 over 4 plus 1 is 5, 5 squared, which is 25, equals negative 4/5. And now we can find where this tangent intersects the y-axis. So we're going to go y minus y1 equals m into x minus x1. And we're going to use a and the gradient that we've got to see where this is going to go. So y minus 0 equals negative 4/5 into x minus 2. So we get y equals negative 4/5 x plus 8 over 5. And we want to find out where it intersects the y-axis. the tangent of the curve A intersects the y-axis at C. Okay, intersects y-axis at C. I don't know if we need to find this or not, but let's do it. So if it intersects the y-axis, it's obviously this bit here. So 0, 8 over 5, because at the y-axis x is equal to 0. Now the last part is to show that AC equals this. All I need to do is take this equation of the tangent. I need to just times everything by 5. So I get 5y equals minus 4x plus 8, and I just bring that 4x across that side, and I've proven what they wanted me to prove. Well, that's all we've got for this week, guys. I hope it's been helpful to you. Let me know if you've got any questions. Take care and God bless.